Welcome. So in this video, I'm going to be teaching you on what rotary encoders are. Rotary encoders, they look a little similar to a potentiometer, but they are not potentiometer. As you can see, they have 5 pins. Now, a rotary encoder, also called a shaft encoder, is an electromechanical device that converts the angular position or motion of a shaft or axle to analog or digital output signals. There are two main types of rotary encoder: absolute and incremental. So you can see it here. What I'm holding right here is actually an incremental rotary encoder. As you can see, it has 5 pins. The first pin here is the output A, or you call it the clock. The second pin here is the output B, or you call it the DT. Then the third one here is our switch. Then the fourth one is our VCC. Then the last one here is our ground. Now, this switch, if you watch here, I can press on it. This makes it a switch. So you can make use of the rotation, you can make use of the pressing, depending on what you're trying to do. Now, as you can see, the rotary encoder switch with a breakout board is shown here. You can see without the breakout board how it looks. They look very similar. So in case you find this, you should be able to know how to work with it. They are actually very similar. The unique thing here is there is no resistor like you have behind the board here. You can see resistor used here. You will have to introduce resistors when you're working with this, but with this you don't really need any resistor. So there is nothing actually much different between both of them. Now let's see how this rotary encoder, this incremental rotary encoder that I'm holding, works. This end here, as you can see, when you do a rotation like this, let's say you make a rotation the way you're seeing me do right now, what's happening is that this end, these yellow dots here, are what you're actually rotating. So these yellow dots, they are the positive, that's the VCC or your 5V. The ash here is your ground or your negative. Then this green here is our DT, the blue here is our clock. So the DT and the clock are not moving. The only part that is moving is this and this. So you only have the ash and the yellow part of this moving. So when you rotate, you're actually moving this. Look at what I'm trying to say. Now you can see right now I'm rotating this clockwise. Rotating this clockwise, you can see what is happening here. You can see that the waveform being generated is actually 90 degrees out of phase. Now let's imagine when you go anti-clockwise this other way, what happens? You can see also that the waveform generated is also 90 degrees out of phase. Now let's look at the difference between these two waveforms generated at both cases, during clockwise rotation and anti-clockwise rotation. Now in clockwise rotation, the clock point here actually generates a waveform that looks like this, while the DT generates a waveform that looks like this. So the DT is 90 degrees out of phase. But when you go anti-clockwise, what happens is that the clock is now 90 degrees out of phase. So the clock starts because when you try to rotate anti-clockwise, what really happens is your DT here your DT is going to be the first to make a contact with this yellow end here. But when you go clockwise, your clock here is going to be the first that is going to make a contact with this yellow end. So in so doing, you can write programs to track each of these hitches, to know when there is a rotation and to know when there is not. So you can use this for increasing a count, reducing a count, controlling motors at different angles, and so on. So it's very precise, very accurate. In fact, I prefer this if you're trying to control something like a motor. This is better to use than a potentiometer. Potentiometer can easily wear out, but with this, you don't have issues with that. It doesn't. You can rotate 360 degree without having any issue. There is no block being introduced. So you're not scared of destroying it, you're not scared of spoiling it. So you can rotate all the way, you can rotate both clockwise and anti-clockwise all the way without having an issue. So this is actually a very best choice when you're looking for a rotational mechanism for control. Thank you.